So welcome back, thanks for coming, and let me introduce the first of our two lunch talks, and it will be delivered by Adi Shavit. Adi is an entrepreneur, speaker, he's also a consultant and experienced software architect. He's also a machine learning expert with an emphasis on real-time applications. Adi specializes in building cross-platform, high-performance software combined with high production quality and maintainable code bases. Adi is also the founder of the Core C++ users group in Israel. And a little bit of an ironic thing, I mean, Adi worked on proprietary software for most of his career, but the most visible contribution to the world of open source software is ironically the design of the OpenCV logo. But hey, exactly. So Adi says that he was coming to our city and Code Dive because he likes the community and interacting with other developers, and also, well, Wrocław is beautiful. Well, tell me something, I don't know. And also that the screens in the cinema are huge. So before we officially welcome with a huge roar of applause, let me just announce a very quick competition. I'd like people on the other side of the internet, so watching online, clap so loud that they're louder than us here in the room. And of course, the room, could I ask you please to be so loud not to let these guys be better than you, okay? So, on my count, 1, 2, 3, Adi Shavit.
Yeah. Okay, thank you for taking time from your lunch break to join me. I hope you're brave enough, because today we're going to take a fun trip into the crypts of C++, and we're going to get a tasting of some of very strange creatures that lurk in the dungeons of C++. And as they said, by day I do a lot of computer vision, AI, I work on autonomous vehicles. But at night, I'm a tour guide into the dungeons and the cellars of C++. And you know, we all know that C++ is a very beginner-friendly language. However, it does have its own sharp edges and dark corners. And in fact, it has some extremely deep cellars. And I hope that you will join me, if you dare, on this tour to see some of these creatures that live in the cellars. C++ has some very figurative and colorful terminology, and I want to share some of these amazing things with you. And a lot of this is quite humorous, but I think that there are also learning opportunities. So as any random list of objects, let's start with A. So the first strange thing that I came upon, a very strange term, was abominable function types. Now, an abominable function type is a type produced by writing a function type followed by a CVRef qualifier. As we can see here, we have using abominable is void, function returning void, essentially it doesn't return anything, doesn't take any arguments, and it's qualified with the const volatile double ref. Now, there is no such thing as a CV qualified function inside the C++ type system. And what we see here, the abominable function type, is actually something entirely different. And it's impossible to actually write a function like this. So how and where could you see this in real code? So the enterprising rectangle type developer wants to be very concise, and they write this simple and obvious struct called rectangle. And on the first line, they're actually declaring this abominable function, or more specifically, it's a method. So we have a method called int property, which returns an integer, doesn't take any arguments, and it's qualified with a const qualifier. This is the abominable function type. Now, the second line is not, it might appear like a declaration of member variables, but in fact, this is the declaration of 6 different methods. So you can see int property is the function declaration type, that the abominable function type we just declared, and top, left, bottom, right, width, and height are in fact for the declarations of methods. And this, don't do this at home. And if you ever see this in any code review, I hope you go and talk to the person who wrote this and explain that this is a very, very bad idea. Okay, but I think it's a very interesting quirk of the type system, and some people are actually trying to see if they can remove it from the type system, although it's not so hard because it's kind of emergent from the way C and C++ are specified, well, C++. Now, another interesting term that many of you might have come across is called duck typing. So duck typing is what's called an application of the duck test for type safety. And the duck test is very familiar to some people by this kind of poem. If it looks like a duck, swims like a duck, and quacks like a duck, then it's probably a duck. It's called abductive reasoning. Basically, it's determining the properties of a type based on the way it's being used and not based by any kind of initial declarations. And in its classical form, it's much more common in dynamic languages. So if you think about languages like JavaScript, and you get an object of some object, you can try to access some of its members, some member functions or member variables. If these exist, then very well, your program continues running. If it doesn't, then you get a runtime error. However, C++ is a statically typed language, so in these cases, the code won't compile. However, C++ does in fact have what's called static duck typing, and this is this is when we're using templates. So whenever we're getting a template parameter type, we don't know anything about this T, and then we can start trying to access some members of this type T, and this is where the duck typing comes in, and this is one of the reasons of the horrible template message error messages, is because you get the errors at the point of instantiation, at the point of use, instead of at the point of declaration. Now, essentially, one of the things that C++20 concepts, hopefully we will get some form of concept soon, is really about template type specification. So we can say what we expect from this type T and its API, such that all those horrible template messages will actually be given at the point of use, at the point of declaration, and not at the point of instantiation, and essentially trying to get rid of duck typing in the static type system. Now, one of the coolest things that we're getting with C++20 is the spaceship operator. I don't know how many of you, who's heard of the spaceship operator? Okay, that's pretty nice, about half of you. So the spaceship operator looks a little bit like a UFO. It's really a three-way comparison operator. So we only need to declare one comparison operator, the spaceship operator, and the compiler will automatically generate the rest of the comparison operators. So the less than, equal, equals, not equals, and so on. And this provides a very consistent interface and a very concise way of defining operators, preventing a lot of bugs when instead of having multiple implementations of each of these operators, now we have just one single implementation, and the compiler makes sure each one of these operations will be as efficient as handwritten code. But that's not all. The spaceship operator actually supports partial ordering and more, and it has some really awesome defaults. So if we want to do write the simple proverbial point class, which has two coordinates, x and y, all we really need to do in order to write the spaceship operator is just declare it auto operator spaceship, taking another point, const qualified, and equals default. So in this case, the compiler will automatically generate the correct comparison operator for this type using a totally ordered. That means that it's going to be lexicographic on the order of declaration of the members, and totally ordered, it means it will work between any two members. So I think this is super awesome, that really one line can replace what would be probably at least 10 or 20 lines of code of much more bug prone and much more verbose code for many use cases. Now, speaking of the kind of magic that compilers do, you know how they say that C++ is Turing complete language, or it's more like maybe 2 Turing complete languages or 5. And the naive programmer who is just starting out working with C++ may think, yeah, sure, C++ is such a powerful language. Of course, it's implemented in C++, right? We include these headers, and everything goes in there is actually implemented in C++. But yeah, so it actually doesn't work like that. If any, some of you have been to Odin's talk, the earlier talk, he gave some example of internal implementations for the compiler that aren't actually implemented in C++ within the compiler. So a few months ago, I tweeted this tweet: how many examples can you name of magical C++? And it turns out, like, I opened a can of worms, because turns out that the compiler actually does lots and lots of magic behind the scenes, and a lot of what we sort of conceptually think of as happening in regular C++ code is actually generated magically by the compiler. So this slide was kind of too small to contain all the answers that I got on Twitter, and here are just a small sample, and I do apologize, some of these people that did answer, didn't have enough room on the slide. So what do we have? Initialization lists. Whenever you use them, they actually generate code of some very unspecified types that go in. We have std launder, atomic, vector, and complex. All of them are, as defined in the standard, are actually unimplementable in portable valid C++ code without magic. Most of the type traits, this is what Odin mentioned, are in fact implemented with compiler magic. Type traits, type info, address of, and there's a lot of other built-in functions. And of course, even what's the first function that runs that we think of? Main. Main is a magical function. It has very, very special properties. I'm not going to go into them now, but main itself is magical. And that's not it, because the compiler is also a code generator, and it generates a lot of code in the background. If you think about integer sequences, range for loops, lambdas, even the spaceship operator that we just saw, all of this really generates a lot of magic, a lot of code by the compiler for us. So I think that's really cool. Maybe I should have put it under Pandora's box. So I only have 3 minutes left. I wanted to show you a few more. This is the maximal munch. I just love this term. Basically, it explains why when we have something like x plus plus y, the code won't compile instead of finding the actual parse, which does compile, but I don't have time to get into that. One final one, which I really like, is that I hate to break it to you, but at some point your program will end. It will perish, it will die, and it will have to go out. And maybe this is by design. Often this is unexpected. And there are many, many ways to die in C++. And I think it's really, really important to know, because you don't want to be surprised. And some of these standard functions in C++, they include exit and abort and terminate and signal and raise. Each one has a different way of and different implications. And I made this graph a couple of years ago. I have the URL here, where you can see what the differences between all these functions are. And again, I think it's funny, but it's actually really important to know, especially if you're working with code that has to be robust. Now, another interesting term that I like is VOLDEMORT types. So these are types that cannot actually be named outside the scope where it's declared, but in fact, it can still be used. It comes from the D language. And if we go into this example, I hope the code is big enough. Yeah, of course it is. So we can see we have this lambda called create Voldemort type. And inside we declare a struct called Voldemort, which has a method called getValue, and we just return an instance of this type. Now, this type cannot be named outside the scope of the lambda because it's internal to the lambda. However, we can use auto to hold it onto it and have and be able to call its method. And we can also use decal type to generate more of these. So I think this is a really cool thing. It sometimes resembles kind of object-oriented programming with opaque types, very common in unnamed objects in concrete factories. So this is a nice idiom, and it's got a cool name. The last one I want to show you is zombies. You know, the standard is a very serious and heavy tome written by, it's an international standard, and you actually have to pay 60 euros to buy the real thing, but it still has a lot of humor in it, if you know where to look. And it has a whole category called zombie names, and if you look in the index, it's actually saying brains, names that want to eat you, and it says living dead, the names of, and really, this is the standard script. It's where all the deprecated functions that are actually gone through the deprecation phase and are now canceled go to die. It's where they're buried, and you can check it out. And Bjarne said there are only two kinds of languages, the ones people complain about and the one nobody uses. So we all love C++, and thank you for listening.
As loud as you can. Thank you very much. Adi Shavit. Thank you, Adi. So we're going to take literally a 5-minute break, switch laptops, and over to the next lunch talk. So join us in 5 minutes.